Hi, today we will discuss few examples related to nucleophilic substitution reactions. You know nucleophilic, we have discussed nucleophilic substitution reactions are mainly two types, SN1 and SN2. Although there are many other types like SN prime, SNAR, but you need to focus on two main types for your examination. So here are a few examples. As I told you, I will give you some more examples. So we can start one by one. In first example, hydroxy is a nucleophile. It's just replacing the halide. Halide may be chloride, bromide or iodide. So it makes alcohol, right? So in these examples, alkyl halide is converted into alcohol. The next example, SH group. H is also acidic, so any base can take the proton and it make a nucleophile as negative. So this nucleophilic sulfur will replace this halide and it will make a thioether. So if you are asked to prepare thioether, this will be a very simple example. In this example, here there are two groups, X and OH. OH cannot be a good leaving group in the presence of a base. So the base will abstract proton from this OH because it's very acidic proton, and then this O negative will act like a nucleophile and it will replace this halide. So in this way, this is an intramolecular nucleophilic substitution reaction. So this will make a tetrahydropyrene ring. Also there are chances to make some product of directly replacement of this OH, because OH is also a nucleophile. So it can replace this X, but this will be the minor product. So the major product will be tetrahydropyrene ring. In the next example, you can see we have taken ammonia as a nucleophile. Although ammonia is a weak base, but it can be in the excess it can be act as a nucleophile. So here this ammonia replace this halide. So this is another example. So this alkyl halide is converted into amine. In the next example, cyanide. Cyanide is acting as a nucleophile, so this will not take on the double bond. This will take on this electrophilic carbon that have the halide group, right? So this halide will be replaced. As a result, this nitrile group will be substituted here. In another example, this carbon have a tertiary carbon and it has some O negative. This may be OH, so a base can take the proton, like here OH is taking proton from this OH group. Similarly here this can be make a good nucleophile. So this nucleophile will take on this carbon and X will leave. As a result, ether will be formed. So this in here, it can be alcohol and alkyl halide. In the presence of some base, you can get the ether. So this is also an example for ether preparation, and it's a very simple example to make the ether. There are the standard procedure method for preparing ether we have discussed. That is a Williamson ether synthesis. That was also similar to this one, but where we were using sodium methyl. So in the last example, you can see we have taken alkyne. Although alkyne is not a good nucleophile, but if we abstract the proton acidic, because alkyne have acidic proton, so if you use a strong base like NaNH2, it will take the proton from the alkyne, right? So this carbon will be nucleophilic. So this nucleophilic carbon will attack on this carbon, that is electrophilic because of the alkyl halide. So this will be a living group and we can get this compound, right? So alkynes can be, can react. So you should know the reactions of alkyne. That alkyne, the proton is acidic, so if you put some base, the base will abstract the proton and make the alkyne nucleophilic. So this nucleophilic alkyne will replace the halide group and it will be the example of SN2 reactions. So I hope by these examples, these are from LGBAT book, so I hope you got some more information about SN2 reactions. Next we will discuss a few complex examples that may have secondary or tertiary alkylates. Mostly you can see they were primary alkyl halides. So primary alkylates give us SN2 reaction, so they were very simple examples. I hope you understand these examples. Allah Hafiz.